Hello, everyone. Good evening. So we are on time. I think we can get started. So yesterday we talked about the introduction. We gave an introduction to R and introduction to Python. And also we talked about the reproducible research with both R and Python. In the case of R, we use R Markdown to document the entire analysis. And in the case of Python, we use Jupyter Notebook to document the entire analysis. And if you look at the R Markdown, we have if you look at the R Markdown, it's a simple document. You have three dashes. We call this as YOMA. And this controls the appearance of the document. And we also here got some code chunk. After that, we start writing our codes. If it's a normal text, we write it just as the way that we do in Microsoft Word. And in the case of R Markdown, if you need to include an R code, what you're doing is you are typing 3 backtick marks and you open curly braces. Inside that, you write little r and you can close this one. We call this one as code chunk in R Markdown. If you want to write a R code, it should always be written within the code chunk. If you write something outside a code chunk, R Markdown will consider it as a plain text. And with respect to Python, we use something called Jupyter Notebook. In Python case, we got cells. And you can remember here by clicking the menu option here, you can open Markdown cells as well as code cells. So if it is a normal text corresponds to this one, you are going to write it within a Markdown cell. If it is a code in a Jupyter Notebook, you're going to write it within a code cell. And also the similarity is if you want to put a title, what we did was we use hashtag followed by whatever the title that you're going to give. So that's the process. Those are the things that we discussed yesterday. And few of you sent me emails asking for the slides. The slides are available on the website here. So the slides are written based on HTML. So if what you need to do is, if you go to any section, click on continue reading. And when you click on continue reading, for example, I will open it in a different tab. You will get a page like this. And click here to view the slides. So you will get the slides corresponds to that section. So here I've got the resources for the R case. And if you go to our main website, you can find the resources corresponds to the Python case. Okay, so, and in addition to that, today I sent you an email. I put our YouTube links. That's where we're going to put the lectures. I will be publishing my lectures on the YouTube channel called Statistics Smart, and Dr. Priyanka Thalagala will publish her recordings on her YouTube channel called Retina Lab. Retina Lab is her research lab, the name of her research lab, which was funded by OWSD UNESCO. Okay, so with that, I'm coming to today's lecture. And today what we're going to discuss is how to create data visualizations using R. Can one of you confirm whether I'm breaking up? Can you hear me clearly? Am I breaking up sometimes? Can one of you in the audience confirm whether you can hear me clearly or am I breaking up sometimes?
I think we can hear you clearly. No problem.
Okay, thank you very much, Samira. Okay. All right. Let's get started with a little bit of introduction to data visualization. And after that, I will explain some principles, data basic principles in visualization in R. And after that, I will give you some exercises. We can solve those problems together. Okay, so let's get started. The first thing that we need to do data visualization is data. So let's suppose that you have data. After that, in order to do data visualization using some software package, what you need to do is you need to organize your data in an appropriate way. So data is the main ingredient that we use to visualize data, and you should always enter your data according to this format. And this format is known as tidy format. So what is this tidy format? You can see here each variable is placed in its columns. Each variable, it has its own column. And the second one is each observation is placed in its own row. So you can see for each and every observation, we have its own row. And the third one is each value is placed in its own cell. Each value has its own cell. So this is the format that you need to follow when entering data. I'm the coordinator of the Statistical Consulting Service of the University of Sri Jawatanapura. And I analyze I help and I provide assistance for lots of projects for the researchers in different fields, medical sciences, the other departments in our faculty, management sciences, allied health sciences. There are a lot. Sometimes when those clients come for a statistical consulting service, they usually enter their data into Excel sheet. The format that they follow is they use different formats. Sometimes they highlight, they combine these cells, they merge these two cells, and then let's say they put male, female. Let's say, for example, age less than 20. Again, they highlight another two merge cells and they put it as age, let's say age greater than 20 or less than 50. Age greater than 50. And then they put male, female, male, female. Likewise, they use different formats. It's one type that I get. There are so many formats that I'm getting. So when I get a data set, before doing data visualization on top of this data set, what I need to do is I need to do some data cleaning in order to get the data according to this tidy format. So this type of a data format is called messy data. And here, before doing data analysis, I need to do lots of data cleaning in order to convert this messy data set into tidy format. Some people call this process as data cleaning. Some people call this as data wrangling. Sometimes people call this as data pre-processing. They all have the same idea. So if I ask you to arrange this into tidy format, what should be the format? What is the format that you are going to follow? I'll give you 1 minute to think about the format. So let's say you got a data set in a format like this. And I want to, before analyzing the data, I want to convert it into the tidy format. Because tidy format is the way that the computer can understand your data. Sorry.
Tianga, you're muted. Tianga, we cannot hear you.
Yes, I got a problem here. Yeah, I just wanted to reload the slides.
Okay, yeah.
Okay, so what I was talking is, so you have a data set. Now the client's data set is like this. So age less than 20 and age between 20 to, let's say, 50 and age greater than 50. And then we have subsections, male, female, male, female, male, female. This is not a tidy format. You can see according to, this is called a messy format. Before doing the data analysis, I want to convert it into the tidy format. This is not tidy because the reason is it doesn't follow this principle. So in our case, each variable is placed in its column. So one variable we have in this data set is age. So you can see the age variable is spread across the column heading. So this is not a tidy format. So ideally, we want to have the age column, age in a separate column like this. Next, the other variable that we have in this data set is the gender column. If you look at the data set, we have two information about the people in the data set, their age and gender. So we need to have another column called gender. If you want, you can include the people ID just to locate the people. So the first person, gender, let's say this first person is male. The first person is male. Age category is age less than 20. If this one is again male, let's say this is first individual, this is second individual, again male, age less than 20. So this is the format that we need. This is the format that the computer can understand. You can't use the other formats. Always make sure to enter your data into the tidy format. Sometimes people think that when you bring the data into a format like this, the statistician could easily understand the data set. Of course, the statistician can easily understand the data set, but statistician is not the one who is going to draw the plots for your data. The computer does the job. So the computer can understand only this format. So when you're entering the data, always enter the data according to the tidy format. Okay. So the next I will go for, okay. For today's work, I need tidyverse package. If you haven't installed it, I recommend you to open your RStudio and let the computer to install Tidyverse. So once we have completed this lecture, we are going to do some data visualization. So if you haven't installed it already, now you can open RStudio and you can let the computer to install the Tidyverse. So when we come to the right point, your computer is ready to do the coding with Tidyverse. Actually, I told you yesterday, Tidyverse is a collection of R packages. Inside Tidyverse, there is a package called ggplot. That's the package that I'm going to use to do data visualization. Okay. Okay, so here I have a one big plot. Within that plot, I have 13 small plots. And we call these small plots as scatter plots. We have X variable for each scatter plot. We have an X variable and we have an Y variable. In addition to that, for each subplot, I have a name. The first one is, the name of the first plot is Dino. The name of the second plot is Away. Here I have circle, bullseye, white line, slant up. Likewise, I have names for each and every plot. Now, my first question is, among these scatter plots, which one exhibits the highest correlation? Among these scatter plots, which one exhibits the highest correlation? Correlation means the co-movement of variables. For example, let's say you plotted two variables X and Y. If you see all of the points fall on a straight line like this, we say it is perfectly positively correlated. As X increases, Y also increases. If you see it the other way around, we say that they are negatively correlated. And when you plot, so here they have a very strong correlation. Actually, there is we call the perfect, they are perfectly correlated. And if you see something like this, if you see, let's say, points like this, then we are saying they are not perfectly correlated, but still there is a strong correlation. And if you see points further scattered, we say there is a poor correlation between the variables, because now the spread is much wider. So usually we measure the correlation coefficient using the Pearson's correlation coefficient. It takes values between -1 and +1. So it measures the strength of the linear relationship between two variables. So according to this plot, what is your guess? Which one exhibits the highest correlation? Can you put your answer into the chat box? Can you put your answer into the chat box? Among these scatter plots, which one exhibits the highest correlation? Okay, good guess. Slant up. Yeah, slant up and slant down. Good guesses. Okay. Okay. So I think Yapa, you know the answer. The other ones, slant up, slant down, they are reasonable guesses. Okay, I will ask another question. Which X variable demonstrates the highest variability? Which X variable demonstrates the highest variability? For example, let's say, I will give you an example here again. So let's say we have X and Y. Let's say we get points like this. And another one, we get points like this. So in this case, you can see with respect to X variable, the X variable is identical for each and every point. So the variability is 0 for the X variable. If you compute the variation of X, you will get 0 in this case, because all of the X values are identical. If you look at this one, you can see there is some sort of variation around a mean value. Let's say the mean is somewhere here, so you can see some sort of variation. Here, towards this side, towards x-axis, you can't see any variation. All the values are identical. Towards y-axis, we have some variation. So my question is now, which X variable demonstrates the highest variability? If we consider all of the plots here, which X variable, which X variable in which plot demonstrate the highest variability? Can I see the answers on the chat box? Which X variable on which plot demonstrate the highest variability? Okay, I'm getting answers as H-line, away, dino, away, reasonable guesses. Reasonable guesses. Okay, now I will show you a small GIF corresponds to these plots. Each time you can see the plots that we saw earlier, and on your right hand side, you can see the mean of X, mean of Y, standard deviation of X, standard deviation of Y, and the correlation coefficient for each and every plot. And here, what you can see is, for all of the plots, these summary statistics, they are identical for 2 decimal places. X bar, mean of X, mean of Y, standard deviation of X, standard deviation of Y, Pearson's correlation, they are all identical for all of these plots. So these are the plots, and you can see the GIF of the plots corresponds to this one. We got star, we got dino, we got high, we got all of these shapes. So what I wanted to highlight is never trust summary statistics alone. Always visualize your data. Sometimes if somebody gives you this, okay, I've got 16 data set, these are the summary statistic. If you just rely only on the summary statistic, you would think, okay, all of the data are identical. It may or it may not. In order to verify that, you should visualize the data. So don't especially if you take correlation coefficient, sometimes people just record the correlation coefficient. It's not right. You should plot the data. Okay. I think that's a good example to identify the importance of data visualization. Okay, the next question is, where have you seen data visualizations? Here I gave you few situations that you see visualizations. Books, you will see plots on books. Sometimes even on storybooks, you can see these data, the data visualizations. Journals, newspapers, TV advertisements, food packagings, mobile apps, and news. Out of these, I highlighted these five items. Do you see any specific difference between these two and these cases? Can you guess why did I categorize these 5 items into one class? And why did I categorize these into one class? Any guesses? I categorized books and journals into one class and the others into another class. Any guesses? Yeah, standard. Yeah, great. Audience. If you look at books and journals, the audience is very specific. If you are writing a book, you know the audience. And for journals also, the audience is very specific. But if you look at newspapers, TV advertisements, food packagings, mobile apps, news, the audience is very broad, very diverse. So when you're doing data visualization, one thing that you need to consider is your audience. So when designing visualization, you need to think whether it will be understood as you wish. And sometimes plots which are common in one kind of field may be unfamiliar to the readers in another field. And also you have to think about the choice of graphical form as well, whether you're going to use a pie chart or box plot or bar chart. You have to think about the graphical form. And also you need to think about the appearance, the appearance of the final product after the print. Okay. Furthermore, what I did was I categorized TV advertisements into one class and the rest into another class. Can you guess the reason? TV advertisement into one class and all the others into another class. Can you guess the reason for this? So earlier I categorized these ones according to the audience. For the bottom part, the audience is very broad. Books and journals audience is narrow. Now I categorize the items like this: TV advertisement into one class and the others into another class. Can you guess the reason? Here, I actually categorize these items according to the time that we have to engage with the chart. So when you have a chart on a book, we have plenty of time to explore or engage with the chart. We have time to read its labels, titles, and everything. Journals, newspapers, food packagings, mobile apps. We'll talk about the news later. We have some time to engage with the chart. But for TV advertisement, it is controlled by the producer of the TV advertisement. So we don't have we can't take we can't take a lot of time as we wish. We need to stick with the time that they take to display the advertisement. So when producing visualization, you also need to think about the time that you give for the audience to engage with the charts. Okay, next one. Mobile apps and news into one category, and books, journals, newspapers, TV advertisements, food packagings into another class. Can you think the reason for this classification? Can you guess the reason for this classification? Mobile apps, news into one category and the rest into another class. Okay, so I will explain it like this. We'll move to the next slide to explain it. So we call this type of graph is a static graph. So it just visualizes the data. We can see these types of visualizations on books, journals, newspapers, TV advertisements, food packaging, sometimes on mobile phones, sometimes on news items as well. This is just giving insights. This is just it's just display some statistics visually. That's it. We call this type of graph as a static graphic. Next one here. In this case, we have someone to explain the data visualization. So this person helps us to identify the key observations. So you can see, if you look at this chart, we don't have that much of information, just the colors. But here you have lots of information. Here we don't even have a title for the chart, right? We don't know what is WA. So those things are not mentioned. We don't know what is represented by blue, what is represented by red, what is represented by yellow. We don't have that many information, just the very small content we have, because the reason is we have someone to explain the chart. So we don't, in this case, when designing the visualization, we don't need to worry about the other content. We just need some picture in order to explain the key concepts. So this is so since we have somebody to explain this chart, we call this as in this case, this data visualization is used for explanatory purposes. So when it comes to news item, you will see this type of graphics quite a lot. So we don't have that many information. We don't have what is X, what is Y. We don't have those information. But if you are representing this, if you are presenting this into a journal, you have to mark the longitude, latitude. You have to give a title for the chart. You need to include a legend to represent what is meant by blue, red, and green. If necessary, you also need to put the names of the states. CO means Colorado, LA means Los Angeles, likewise. So the next type is, okay, here you will see this kind of charts in on mobile apps. So can you identify the difference here compared to the other two? Here we have lots of information that you usually see on newspapers, journals sometimes. Here we don't have that many information, only the key observations. Here, what is the difference? You will see this, you can find these types of charts on mobile phones quite a lot, or sometimes apps. Sometimes you will see these ones on dashboards visualization. What is the difference compared to the previous ones? We don't have anyone to explain this, explain the key observations, but what is the difference? Yeah. One observation that the one answer that I got was drill down. You have these drop down menus here in this case. So in other words, in this case, the designer gave the user a chance to interact with the plot. We don't have anybody to explain the key observations, but the producer gave us some options to navigate the plot on our own. If you want, you can enlarge the areas. Here we have the results for 2017. If you want, you can change the year, you can change the states. Likewise, we can navigate, we can explore we can interact with the plot on our own. So we call this one as in this case, the data visualization is used for exploratory purposes. First one is explanatory. So this one is explanatory, the earlier one, because we have somebody to explain this one, explain the project, explain the key observations. Here, this one is there's nobody to explain the things, but it has some features that that allow us to interact with the chart. So always, when creating visualization, you need to think about the audience and the format, the output format. Depending on those things, you can decide whether it is necessary to add a title to the chart, whether it's necessary to add the color coding to the charts. Those things, all of those things depends on the audience. Okay. Next, what I'm going to here, you can see the Irish data set. I introduced Irish data set yesterday. If you look at the Irish data set, we have 100. Actually, here you can see only the part of it. We have sepal length, sepal width, petal length, and petal width, and we also have the species type. So you can see, by looking at this numerical information, we can't identify any patterns inside the data. Processing numerical information in raw data is very challenging. However, visualizations offer a powerful solution to make data more accessible and easy to read. Here's an example. Here in this case, what I did was I plotted the scatter plot between the two variables, sepal width and sepal length. Now you can clearly identify the relationship between these two variables across the species category. You can see this relationship varies according to the species type. This is the relationship between sepal width and sepal length for the Setosa type. And this is the relationship between the other two species for the of the Irish flower. You can see that the Setosa type is very different compared to the other one. We can't say that this is significantly different, in order to see whether it's significantly different or not, statistically significantly, whether this difference is statistically significant or not, you have to do some hypothesis testing. But visually, we can see that setosa type is slightly different compared to the other species type. We don't know whether this difference is statistically significant or not. For that, you can use hypothesis testing. I'm not going to cover the hypothesis testing in this case. It's just based on here, this one is just purely about the visualization. Actually, here you can see some differences across the species type. In order to see whether this difference is statistically significant or not, you need to use the hypothesis test. Okay. Now let's see what is data visualization. So here is the definition given by given by a famous data visualizer, Andy Kirk. He mentioned the data visualization, the visual representation and presentation of data to facilitate understanding. Data visualization is the visual representation and presentation of data to facilitate understanding. So we have 4 phrases: visual representation, presentation, data, and facilitate understanding. Here, the most important word is data because it's the main ingredient. Without data, we can't do data visualization. Next important thing is visual representation. So the visual representation means how are you going to plot your data? So what are the building blocks of the charts? Whether you are going to use points, lines, or shapes. For example, let's say you have some data like this. Let's say we have daily temperature. January 1st, 2nd, likewise, you have the daily temperature. So one can represent data like this, like points. Or else another one can represent this data using a line like this. Connect the observation using a line. Or else another one can represent the data using both lines and points. So you need to think in the visual representation, how are you going to plot data? What are the main building blocks of the charts? That's called visual representation. Next one is presentation. So we take raw data and we visually converting it to charts and charts. And here what we need to think about, what we need to think is the design decisions. For example, whether are we going to make this chart interactive? Likewise here, for example, in this case, maybe we can put all of the details like this and present. Or else we can just use this part and we can put somebody to explain the key observations. Or else what we can do is we can add some options that allows user to interact with the chart. So that's what we mean by the presentation. So the visual representation means you decide how you are going to plot your data. And here you have to think about the presentation. Presentation type of the plot. Next one, the final one, final word that I have here in the definition is facilitate understanding. In visualization, we can create charts, but we can't guarantee the understanding of the audience. We can only do to facilitate their understanding. Sometimes they need some basic knowledge in order to read the data appropriately. So we can draw the best chart that we can get for the data, but we can't guarantee the understanding of the audience. We can only facilitate their understanding. Okay. Now what I did was, so I have sepal length, sepal width, petal length, and petal width and species. Based on this data set, I created 4 plots. First, can you identify the variables that I put on the plots? Can you identify the variables that I put on each of these plots? When you get a chart, the first thing that you need to do is you need to identify the variables. What are the variables that I have put onto the plots? If you look at first one, you can see the variable that I considered is sepal length, sepal length and species. Y-axis represents sepal length, x-axis represents species. So you can see this one and this one. And if you go to our plot, we consider these two. Sepal length and species, first column and the last column. Those are the 2 columns that I use in order to create the first chart. What can you say about the second one here? You can see the appearance of the plot is drastically different, but still I use the same 2 variables, sepal length and species. And if you look at this one, again, I use the same set of variables, sepal length and species. If you look at the last one, again, I use the same variable, sepal length and species. So here I got just 4 plots, but I wanted to highlight is, for a given situation, there are many plots that you can draw for that situation, in order to represent the relationship of that relationship of the variables corresponds to that situation. So in order to, here in this case, you can see, in order to represent the relationship between sepal length and species, here I plotted all of the points on a single line like this. Here we call this one as box and whisker plots. Here I use box and whisker plots to represent the data. Here I use some point clouds, and here I use again box plots and point clouds. And here, now for this one, can you identify the variables on the plots? First plot. Now, can you identify the variables that I put onto the plot? Can you put the answers into the chat box? What are the variables that I use to create the plots? Always, when you get a chart, the first thing that you need to do is you need to identify the variables. After that, you can interpret the plots. Without identifying the variables, you can't interpret the plots. So in order to identify the variables, there are a few places that you need to look at. You need to look at the y-axis label. You need to look at x-axis label. And if there is a legend, you can look at the legend as well. So in this case, you can see earlier, I've got only two, sepal length and species, for all of these plots. Here, now I added another variable. What I did was I colored the points according to the species type. So my third variable is, again, you can see it added this legend. I just color the points according to the species type, but still I use just two variables. The same two variables that I used, but now what I did was I just color the points according to the species type, so that people can easily identify, okay, this is the setosa and this is the other type and this is the other one. So you can see there are many things that you can do on top of on a plot in order to make it visually appealing. Actually, when you're, let's say somebody asks you to draw a plot X and Y, let's say X is a qualitative variable and the other one is a quantitative variable. One variable is qualitative, the other one is quantitative. So there are many options. So here you can see here I here illustrated 8 options. Here I got 4 charts and previous slide I got 4 charts. There are so many options. And as a visualizer, you need to think about the best choice. The thing that you are going to use in order to deliver the final product. So out of this bundle of options, in order to decide the final, in order to take a decision, you need to learn some best practices. As well as you also need to think about the you also need to think about the other constraints. You need to think about the audience. You also need to think about the time you have and the tools you have. Let's say somebody asks you to do a visualization for the relationship between one categorical variable and one quantitative variable, like the one that you see here. And the person just give you a paper and a pencil. So you can see, even though there are lots of options here, according to the availability of tools, you can just go for the only a basic type of plot like this. If you are given just a pen and just a pencil and a paper, this is the easiest to draw. You just need some summary statistic and you can easily draw this one. This is a little bit hard because you have to place the points correctly. So when creating visualization, even though you have lots of options, you also need to think about the other constraints, such as time, tools, audience, and final output. Especially, let's say you are submitting a paper to a journal and the journal print everything black and white, then no point of wasting your time to create this type of visualization because the end product is black and white. So you need to think about, you need to select a visualization from here. So the planning is very important when it comes to visualization. It's like building a house. Okay. So you can see on all of these plots, I use the same Cartesian coordinate, same variables, and the way that I map the variables into Cartesian coordinates is also the same. On all of these plots, I use sepal length for y-axis and species for x-axis. The only difference is the things that you see on the chart. If you look at the first chart, these two charts, in order to represent data, I use points. And the way I place the points are, the way that I place the points are slightly different. So if you look at the first option, here what I did was, I will go to my data set here in order to explain the first plot. So this is how I created the plot. X-axis, Y-axis. If you look at this one, I have 3 species type. I will call it as S, V1, and V2. And let's say the first species type is Setosa. Sepal length is 5.1. So I marked 5.1 here. Next one is 4.9, 4.7. And you can see there are 2 flowers with sepal length 5 point. So I will get a point here again on top of this one. Likewise, I mark the points. If I get 2 points again, I mark on top of the same point, but likewise, I created the first plot. What is the main disadvantage that you see on this plot? What is the main disadvantage that you see on this plot? The first plot. If you look at this point, here, we don't know whether this is whether this point represents a single observation or multiple observations. The disadvantage of this plot is we can't identify the overlapping points. Because if you get the same value, you color that observation on the same point. So the disadvantage of using this plot is we can't identify the overlapping observations. That's the disadvantage. So in order to overcome that, so this type of geometry that we call in R, we call this type of geometry as points. We represent all of the point observations using single points, but we can't identify overlapping observations. So in order to overcome this problem, when creating the next one, this is we have in this case point cloud. In R, we call this as jitter. When you see a point cloud, we called it as jitter. Here, the geometric objects that we use to represent data is points. Here, the geometric object that we use to represent the data is called jitter. That's the term that we use in R. Now, in this case, what I did was, I added random noise around the point. So you can see a small noise is added. Now this point is placed here. So we can clearly see here there are no overlapping points, just one single observation. And here you can see on top we have 2 points like this, and you can see them here. The advantage of this one is we can clearly identify, so we can overcome the problem of overplotting. Next, if you look at the next chart, this one, here what I did was, so earlier, if I go to data, I got data sepal length, and I've got species. And all of these observations are represented through the points. When creating this one, what I did was, first of all, based on these data, I created summary statistics. I created summary statistic called a median, first quartile, third quartile. I also created, in order to, so this one is, this is Q1 median and Q3. And here you will use a value called Q3 plus 3 times interquartile range. Interquartile range means Q3 minus Q1. And here I also computed another value, Q1 minus 3 times interquartile range. Interquartile range means Q3 minus Q1. Because before plotting data, I computed some summary statistics. After that, I plotted these summary statistics on the chart here. Now here you can see this one is Q1. This is Q2. This is Q3. And around that, I created a box. And these two values, this value is represented here, and this value is represented here. And anything outside the region is denoted using a point. So with respect to box plot, if you see observations, we call them as outliers. So you can see, even though I use same data here, before plotting the data, I applied some transformation. Applied the transformation means based on this, I calculated some summary statistics. The graphical components that we use when creating charts, depending on the audience, you can think which ones that you're going to put on the plot, which ones you're going to remove from the plots. So this one is, you can see this one is, they are called the y-axis. Well, this is x-axis. If you are especially doing a plot for some academic journal, you need to be very careful about all of these components. So here we call this one as axis title. Here y-axis title, x-axis title, and we have a main title and subtitle and legend title, legend labels. We have major axis, minor axis, and axis labels. So all of these things are very important when it comes to creating graphics. Okay. Now let's try to create, let's try to understand how we can create these graphics using R. So in order to view the slides, so you can see on the page, only up to this one. If you click on all the post, you can get into other slides. Okay. So yesterday also we talked about this data science workflow in R. So we start with reading data, tidy data. Jointly we call these two as a data cleaning. And then we go for visualization, modeling, communication, and automate. We discussed this one, how to document your analysis. And today we're going to focus on this part, ggplot2, how to create graphics using data visualization. I will share the link. Last year we conducted a workshop covering all of these components. I will share the course website. So if you want, you can. You have some materials there. Okay. Okay. Today, if you look at the title. So data visualization with R. And here the package that we're going to use is called the ggplot2. Here GG stands for Grammar of Graphics. Grammar of Graphics for plotting. GG means Grammar of Graphics. We are all familiar with grammar in a language. If we know English grammar, Sinhala grammar likewise. So here, they introduce a grammar to create any kind of plot. In English, we have verbs, prepositions, articles, adjectives to form new sentence. Likewise, in Grammar of Graphics, we have plotting elements. These are the components that we have in Grammar of Plots. In English, we have these components. By using these components, we can create a new sentence. For example, something like this. Here I created a new sentence. The little monkey hangs confidently by a branch. I use article, adjectives, nouns, verbs, adverbs, prepositions, and nouns. Here, what I did was I used Grammar of Graphics to create a new chart. We put together these components in order to create a new graph like this. Just like you put nouns, verbs, and adjectives to put a new sentence. So this is a very powerful concept to organize all kinds of data graphics. So why we should learn grammar? In English also, if you are familiar with only a limited number of phrases, you may be able to get by in certain situations. Suppose you know some common phrases. How are you? I'm fine, thank you. Good morning, good evening. Just with a few sentences, you can survive. However, this, if you know only limited number of phrases, what happens is it restricts your ability to efficiently convey and elaborate your ideas. It limits your opportunities to fully express your thoughts in a very comprehensive manner. If you know only just few phrases, you are very restricted. You are not free to elaborate all of your thoughts. So the same thing happens in visualization as well. Suppose you know how to draw only a pie chart, how to draw only a scatter plot. Then you restrict yourself. If you want to explore new things, present new things, even though you have that thought, you won't be able to put it into a paper or onto your document because you don't know how to draw it. So in order to overcome this problem, they introduced this grammar of graphics concept. Okay. This concept was introduced by Leland Wilkinson. If you want, you can read this book, Grammar of Graphics. But he didn't implement this framework. Later on, Hadley became the chief scientist at RStudio. He implemented this grammar of graphic framework in a plot called ggplot. Actually, it was the outcome of his PhD thesis. Now they have expanded this package, and Priyanka and I we worked on this package when we attended IASSL conference in France in 2019. There are so many contributors to the package. So they have now the new version. Then they named the new version of the package as ggplot2. Okay, let's try to understand the concept. So sometimes you might be familiar with the base R graphics. That means the default graphics without installing tidyverse. With just the installation of the default version of R, you can create some graphics. And this is the appearance that you get when you want to create graphics. So you can see here, their syntax is very different. Here, in order to create a pie chart, they use pi. And this is how you should pass the labels. If you want to create a bar chart, again, a separate function name and the syntax is different. This is how you should create a line chart. This is how you should create a scatter plot. In base R graphics, they considered the plots as separate entities. So, but this is very restrictive. You need to stick with the functions available, the functions given in base R. But with ggplot, they bring all of the plots into a single framework. Rather than considering these as separate entities, now they bring all of the plots under a one umbrella. By using these components, you can create any kind of graphics. So in other words, this grammar of graphics, in other words, this grammar of graphics framework provides a systematic way of describing any kind of plots. Just by using these 8 components, you can create many plots. But with the base R, it's different. There are separate names for each and every plot. If you want to be creative and if you want to introduce a new plot, that's quite challenging. And if you want to draw a new kind of plot, if it is not if you cannot find a function for that, you won't be able to draw it. But here, this is very flexible framework. You can draw any kind of plot. And this is a very consistent format. And the other advantage of using ggplot is, ggplot has a large active user community. So because of that, there are many online resources, tutorials, examples available on the internet. Okay. Now let's see how to create graphics with ggplot2. So in order to create graphics with ggplot2, first of all, you need, if you have already installed it, you don't need to install it again, but you need to open the package. So in order to open the package, you can do 2 things. One thing that you can do is you can type library and you can type the name of the package, ggplot2. Yesterday I told you whenever you want to use some function inside the package, first of all, you open the package. You need to open the package. And this is how we open the package. Or else, you can type the command in order to open the ggplot2 package. You can type the command tidyverse. And here the advantage is this will not open only ggplot2. It will open all of the packages inside the tidyverse. If you type this command, it will open only ggplot2. If you open ggplot2 through tidyverse, it will open not only ggplot2, all of the packages under the tidyverse. So if you have already installed it, these are the 2 commands that you can use one of these commands in order to open the ggplot2. Okay. If your computers, if you have tidyverse installed, you can maybe click library ggplot2. Okay, let's first look at the first layer, that is data. In order to illustrate the concept, today I'm going to use a new data set, Palmer penguins. This data set is about the physical properties of penguins. Yesterday and today also I use Irish data set. I told you Irish data set is a built-in data set. It is very similar to built-in feature of of an equipment. So here in Irish dataset with the default installation, you will get the Irish dataset. You don't need to install any packages in order to load the Irish dataset. With the default installation, you can just type Irish, then it will load the package. But in order to work with the penguins dataset, you need to install this package. The name of this package is Parma Penguins. In order to work with the penguins dataset, you first need to install Parma Penguins package. If you want, I can show you how to install this package, very similar to the way that we discussed for the other packages. So what I'm going to do is I go to packages, install packages, and I type the name Parma Penguins. So here you can see the name here. So I click on that one and click on install dependencies and click install packages. So you can see the installation of the package here. Once it's installed, you will get the command prompt like this. Now I installed the package. In order to work with the package, I want to open the package. So I can type library Parma Penguins. Now the package is open. Next, I want to load the penguins data set inside the package. In order to load the penguins data set inside the package, you can type here data penguins. If you want to view the description of the penguins data set, you can type $penguins to get access to the help file of the package. So in this data set, we got 344 rows and we have 8 variables. We have the species type of penguins, we have their island, their location, we have some information about their body, about their physical characteristics and gender. And another variable we have integer denoting the study year. If you want to view the entire data set, another command that you can use is capital VIEW penguins. You can view the entire data set here. The information corresponds to all of the penguins. So this is the data set that I'm going to use in order to illustrate the grammar of graphics. So now you have some idea about the data set. So we have the bill length. A bill length is this beak length. And also we have bill depth. We have flipper length. Flipper length means the length of the flipper. And also we have body marks. This is the data set that I'm going to use. Okay. Next thing that I need to do is, this is very similar to the way that you draw a plot using pen and pencil. Let's suppose that you need to draw a plot using pen and pencil. The first thing that you need to do is you need to take a paper. Same thing happens in ggplot as well. First, you need to take a paper. In order to take a paper, you need to type this command ggplot blank ggplot round parenthesis, and inside the parenthesis we don't pass anything. So this will give us a paper to draw the plot. After that, what we need to do is we take a paper, then we have to introduce our data set, because it is the main ingredient that we need in order to do the plotting. So this is how we introduce the data set. Inside ggplot command, we use data equal, and here you can give the name of the data set. If you are using Irish data set, you can give the name as Irish. If you're using some other data set, you have to give the name of the data set. So we did two things so far. We first take a paper. Taking a paper is similar to ggplot, just typing the command ggplot. And the next thing is we introduce the data set, because that's the main ingredient that we need in order to do the plot. All right. After that, so that we completed the first layer, data layer. So we learned how to introduce our data. We learned how to take a paper and how to introduce our data set to ggplot. So we completed the first layer. Very easy. Next one is mapping. I told you always when making a plot, what you are doing is you map variables to the graphical properties. You map variables to graphical properties. If you look at any plot, the creator mapped the variables to graphical properties. So this is how you should map the variables to graphical properties. Now we learned up to this one. So after that, inside ggplot inside the same ggplot2 command, separated here, you can see I have put a comma. Then you have to pass mapping equals is 30, and here you have to pass the arguments. I want to map flipper length to x-axis. I want to map the variable body mask into the graphical property, that is y-axis. So that's the next step. The first step is, so you can see all of the commands that we have introduced so far, they are all listed inside this ggplot2 command. If you have any questions, please feel free to ask or put it into the chat box. So you can see here in this case, so the first thing that we did was we introduced our data set. That's the main element. And after that, we also pass another element, that is mapping. We map the variables to the graphical properties. So you can see everything is listed inside the ggplot2 command. and these two are comma separated. When mapping variables, we need to use the name mapping equals aesthetic. Okay, the first graphical property is X. The we map flipper length to X. Next one is Y. We map the variable body mass underscore G to the Y value. Introduce your data set and then you do the mapping. That's it. Next one. Okay. So we completed 2 layers, right? We learned how to introduce our data set and we learned how to do the mapping, how to map the variables to the graphical properties. After that, we want to decide the geometries, the things that we want to see on the chart, whether it's a point or a line or box plot or histograms. Likewise, you have to decide on your geometries. So let's look at how to decide the geometry. After that, what you are doing is now we added the next layer. We call this one as the layer. So you can see now I use plus sign and add the layer geom point. Yeah, I'm telling R, I want to represent my data using points. Always, when it comes to geom layer, it starts with geom underscore. And here you can see the point, box plot, histogram. I will give a list of geoms, then you can explore them. Okay. So those are the 3 key elements that we need in order to draw a plot. What are they? We need data layer, because without data, we can't do any plotting. After that, we need to map your variables to the graphical properties. So if you just map the variables to the graphical properties, you will get a chart like this. Still, we can't see the data. Then we have to tell R what is the geometry that we would like to have on our chart to represent data. So here I tell R, I want to represent my data using points. So now you get the points. So in order to draw, in order to do a plotting, we must specify these 3 components: data, mapping, and geometries. These 3 are essential. The other layers are optional. We must specify the data layer, we must specify the mapping layer, and we must specify the geometry layer. Why we call these as layers? The reason is, if I go to the first plot, okay, first I introduce the data. Now suppose next what I did was, on the same plot, I placed a layer. Suppose you draw these grid lines and these numbers and the title of the x-axis on a transparent paper, and you placed it on this panel. Then you will get this chart. When it comes to next chart, what you did was, now you have 2 layers. On top of that, you place the point layer. So you can see we can decompose the graph into layers. First the blank paper, and then the grid layer, and then the geometry layer. It's like placing layers on top of each other. Okay. Now I will give you a small exercise. What I want you to do is, I want you to draw a scatter plot between sepal length and sepal width for the Irish data set. So if you go to your turn, I have some questions here given. You know 3 layers. I want you to draw a scatter plot between sepal length and sepal width. Okay, let's go with start with this one. Let's document your analysis using R Markdown. So I want you to open R Markdown and document your analysis there. So I will give you 5 minutes just to open R Markdown, and maybe you can save it, and after that we can go to the other steps. Open R Markdown and save it. After that we can go to the other steps. I hope you can see the time as well as my R Markdown document. As my R window. Can you remember the steps that we used yesterday? You can go to File, New File, and go to R Markdown. File, New File, R Markdown. And if you want, you can give a title. I will just stick with the default. And I will select HTML. You will get a plot like this. You will get a template like this. In order to see the output file, you can press on the knit button here. So you can specify a place to save. I will save it inside download folder day 2. So you will get a template like this. This is not the one that we want. Now you know how to edit it. I will remove all of these things. I don't need them. These also I don't need. So I got a blank document, so which is ready to do the rest of the analysis. If you have any questions, you can ask because we have some time. Okay. So we are ready with our markdown document. The next point that I have is we want to load the tidyverse in order to tidyverse on our markdown document, because we're going to draw the ggplot. We need the ggplot2 package. So I will give you 3 minutes. So we want to load the tidyverse package. So what I'm going to do is it's going to be an R code. First, I open a code chunk and type tidyverse. Then type a library tidyverse. And run it in order to get the output file. So I loaded the tidyverse package. You can see all the packages inside the tidyverse. Okay. If you get any issues, just let us know. We can help you. If you are done with the code, you can draw a scatter plot between sepal length and sepal width. Sepal width, the variables in the Irish data set on the R markdown document. If you open your turn slide set, there are a couple of questions. You can follow them. Okay. Next question that I have is load Irish data set. It's very simple. Now, in order to do the data, we can load the Irish data set. If you load the Irish data set, it will load the entire data set on your R markdown document. If you go to your R markdown, you can see the entire data set. So this is so in order to, we don't need to see the entire data set. Let's suppose we want to display only the first 6 rows of the data set. So what you can do is you can here type head Irish. Now you will see only the first 6 rows of the data set. If you want, you can add a title to your markdown document. Next question is, so if you want to look at the summary statistics of the data set, you can type another command. If you want to get an idea about the summary statistic, you can type summary IH. You will see the summary statistics of the data set. Okay, now I will give you 5 minutes for this one. I want you to draw a scatter plot between sepal length and sepal width. Okay, today it would be better if you can, if you have any questions related to the R markdown and everything. If you, it's better if you can put it into the you can put it the message. You can put the message into the chat box, or you can directly write to me. So I got a question. The question is about how to get a blank R markdown document. I have already explained it. So let's say you get a template. This is the template, default template. And I'm going to delete everything after R markdown. This is available on your slides as well. And I'm going to delete title, author, date as well. Always, in order to get the output file, you need to press the knit button. When you press the knit button for the first time, you will get a window like this. You have to give a name for that one. I will give the name as day 22. Then you will get a blank document. This is the format that you need to use in order to get the blank document. This is the format that you need to use on your R markdown document. Always, in order to get the output file, you need to click on the knit button. In order to get the output file, always click on the knit button. In order to get the HTML output file, you always need to get the knit button. Any other questions? If you have written the code, you can put it into the chat box. If you get an error message with the code, you can also put that into the chat box. So I can help you to fix the error. You can, if you want, you can put your answer into the chat box. If the answer is wrong, that's all right. You can even put that into the chat box so that we can discuss the error. Okay, let's discuss the answer. I'm going to open, okay, I will open a title, plotting, a scatter plot. Maybe I can meet. So I open a new section to document my work. So first of all, you need to open our code chunk. This is where I'm going to write my code. First thing is I want to get a paper. In order to draw the plotting, I want to get a paper. So when you type this command, it will open a paper. After that, what I'm going to do is I want to introduce my data set. I want to introduce my data set to the ggplot. So data, the name of the data set is Irish. And you introduce your data set to the ggplot because without data, we can't do anything. Okay, so with this, I completed the first layer. Next thing that I want to do is I want to introduce the mapping. I want to map the variables to the graphical properties. So you can use mapping equals AES. And inside this, you can do the mapping. So I want to map, let's say X, okay, I will use X. I'm going to map sepal length to the X variable and Y sepal width. Okay, if I run this one, so you won't see anything, just the Cartesian coordinate. After that, I want to tell them the way that I want to visualize this data set. So I want to visualize all of the observations using points. So in this case, I'm going to use the layer, the geometry that I'm going to use in order to represent data is geom point. I add the layer geom point. So when you run this, now you should be able to see the plot. Another, okay, so you can see now that you can see the code as well as the plot. Very easy, the same thing that we did for the other case. So another thing that I'm going to use is, I told you one of the difficulties with ggplot is, point layer is, we can't see the overlapping points. Another one way to overcome that problem is use geom jitter option. But in this case, geom jitter option is not suitable because the exact position on the scatter plot is very important in this case. This exact position, this location, it has a specific meaning. It gives my X, the associated X value for the observation as well as associated Y value for the observation. Earlier case, I got here Setosa and the other two species, and here towards Y-axis, I got sepal length, and I just draw the points. In this case here, we don't have a numerical value. They are just qualitative variables. So in that circumstance, it's all right to use jitter option to see the spread of the points. But in this case, it's not a good idea. It's not correct to use geom points. Sorry, geom jitter. Use geom points because this exact location is very important. It's good that you put that answer into the chat box so that others can also learn. And in this case, in order to overcome the problem of overlapping, what we can do is we can add an alpha value. We can also do this for the previous case as well. So I add an alpha value, alpha 0.5. Inside geom point, I add an alpha value, alpha 0.5. When you run this, okay, now you can see through the points. If you enlarge this one, you will be able to see through the points. You can see these points are much darker than the others. That's because we have overlapping points. Here, this one is darker than the other. This one is darker than the other. That's because we have overlapping points. 0.05, let's make it. Okay, that's too dark. Maybe 0.1. Yeah, you will be able to see some dark points. If you want to change the size of the points, you can use size, let's say, suppose 0.2. You can change the size of the points. Okay, you can see here some points are dark. That's because of the overlapping case. Okay. Okay, let's go to the slides and we'll come back to slide number 8 later. Okay. Next thing that I wanted to mention is here you can see in this case, I put this mapping layer inside the ggplot function. This goes inside my ggplot function. When you go to the next slide, you can see I put the same content inside the geom point, inside the geom point component. Earlier, the same thing, the pink color area was here. Now I placed it inside geom point. Here, the difference is, let's suppose we later on add another layer to this one. We can add another layer, maybe geom density or something. We can add many geometric layers to the plots. Can you remember in one of the previous graphs, I added 2 layers. I represent data using box plots as well as I visualize the data, the individual points using points. So I use two things. Similarly, here also we can add many layers. If you add this mapping inside the ggplot layer, if you add this mapping inside the ggplot layer, then any layer that's common to all of the other layers. So we in that case, that mapping becomes global. It's common to all of the layers. If you placed it inside the ggplot layer here, then all the other layers will use the same mapping. If you place this inside this geom point layer, this mapping works only within this layer. If we place this component only within this geom point layer, then it will work only within that layer. That's now it's become local. If you specify this mapping inside geom point, then it's common. Any layer can use that information. If you specify that within a specific layer, specific geom layer, then only that layer can recognize it. So this is called this is now this information is local, because only this layer can recognize it. Earlier, it was common to any layer because we specified it within the ggplot layer. Now we are specify it only within the geom point layer. Okay. Again, let's suppose, so we talked about only two graphical properties, X and Y. You can map the variables to the other graphical properties. For example, I want to color the points according to the species type. So I'm going to map the variable species to the color, to the graphical property color. Furthermore, suppose you want to change the shape of the points according to the species type. You want to change the shape of the points according to the species type. So what I did was, I mapped the variable species to the graphical property shape. So now you can see here, I have mapped, I use three variables. I map those variables to 4 graphical properties. What are the graphical properties that I use? X, Y, color, shape. And the variables, flipper length, body mass, species. When you are given a plot, the very first thing that you need to do is, you need to identify the graphical properties and the variables. After that, only you should think about the other interpretations. Without identifying the graphical properties they use and the variables, you can't make any interpretations. Okay. Furthermore, if you want, what I wanted to do is, I want to color the points if flipper length less than 205, I want to color it using a 1 color. If the flipper length is greater than 205, I want to color it using another color. So for that, you can also, so earlier, all of those cases, we just map the variables, flipper length, body mass, the species, and here also again the species. Now in this case, I can specify a relation like this. Flipper length less than 205. So within this mapping, it's not just variables. You can specify the relation. You can use this type of, you can specify these kinds of relations as well. Now you can see on the plot, points are colored according to the flipper length. If flipper length is less than 205, we have them in green. And if it is greater than 205, we have them in orange. So you can use any kind of logical operations here. That's another advantage that we have with the grammar of graphics. Okay, next one. Okay, next one. Here, what I did was, in the earlier case, what I did was, I mapped a variable to the graphical property color. You can see in all of these cases, this mapping happens inside the aesthetic. Here also, the mapping happens inside the aesthetic. If you want, you can here put mapping equals. I just removed it. It will automatically identify this is equal, the mapping equal. If you want, you can remove this part. That part is option. So anyway, all of these mappings, they occur inside the aesthetic function, AES. Inside the aesthetic. Now, if you look at this plot, here the difference is, you can see now the color is set to purple. It is done outside the aesthetic function. So here, in this case, the reason is there is no mapping. We didn't map any variable to the color. We just set a color to all of the points. So since it is not a mapping, we don't need to specify it within aesthetic. We can specify it outside the aesthetic because it's not a mapping. It's not a mapping, it's just setting a color. Earlier, we want to color the points according to a variable. So setting a color and mapping a color, they are two different things. Mapping a color means you map a color to a variable. Setting a color means you set the color for all of the points. Next one is, so I added 2 layers. So here you can see, in addition to geom point layer, I also added a density layer. So you can see, in order to add a density layer, I use density underscore 2D. And here, in this case also, the aesthetic mapping, it is defined inside the ggplot function, inside the ggplot component. So this mapping is common to all of these layers. This becomes global. This mapping operates for each and every layer. So if we go to the other command, so here is another one. In this case, I wanted to draw a histogram for the flipper length. I wanted to draw a histogram for the flipper length. So what I did was, first of all, I defined the ggplot, and I introduced my data set. And after that, inside the geom histogram, if you want to draw a histogram, this is the geometry type that we use, geom_histogram. Inside that, you just map the variable that you want to plot. If you want, you can bring this here. Okay. So you can clearly see the difference here. Here the mapping and data, they are all defined inside the ggplot. So this information will become global. And this information operates under each layer. Here, if you look at this side, now you can see you have only points. Because you introduce your data, you introduce your mapping only to the geom point layer. Only geom point layer has access to this information. Even though you added geom_density 2D, you won't see the lines like this, as you see here. That's because this layer, the last layer, this layer, it doesn't have access to these information. It doesn't have access to these information. It cannot read those information. But if you specify it within the ggplot, then it becomes global. Even this layer can access it. This layer can also access it. But here, this is specific only for geom point layer. If you have any questions, please feel free to ask. Okay, now let's go back to our exercises. Okay, now I want you to do this one. Color the points according to the species type. Go back to the Irish data set and color the points according to the species type. If you get any codes with errors, put it into the chat box. We can help you to figure out the error. So what you can do is color the points according to the species. So that means a mapping. So inside this aesthetic, you can put COL, or else you can use the full word, or you can use the full word, or you can use the first three letters. So the name is species. Now we color the points according to the species type. Okay. Next question is, obtain a suitable visualization to represent the relationship between species type and the petal type, petal length. We will use box plots. If you are using box plot, the geom name of the geom layer is geom box plot. And suppose I want to draw something like this. Sorry. And I want a species to be here, Setosa, and the other two types, and I want to draw a box plot like this. Write the code. Yeah, I will use the answer on the chat box. You will get this one. And so I just use a answer on the chat box. So she has put a size to the outlines of the box plot. That's why the outline is much bigger, thicker. So likewise, you can customize this one. If you want to, I will remove the size. If you want to fill the box plots, here you can see the outline. Outline of the box plot is colored according to the species type. If you want to fill these box plot, so that's another graphical property. What we can do is we can here put fill equals species. So you can see now the box plots are filled according to the species. So the graphical properties that we use here, they are X Y color as well as fill. So she also added alpha value to see through the points. That's not very important for the box plot, but in order to make your box plots visually appealing, you can put alpha value as well. And I will add geom point layer on top of this box plot. Plus geom point. So it's like you plot the points on a transparent paper and add it at the points on top of the box plot. If you want to make it a point cloud, you can add geom jitter. If I put this mapping color only inside geom box plot layer, I put color only inside geom box plot layer. Geom box plot layer. Can you identify the error here? Can you identify the error here? I'm getting an error. The reason is always, so inside geom box plot layer, I did the mapping. Always the mapping should occur inside the aesthetic function, AES. So I should put this one inside aesthetic function. Again, an error. Okay. So aesthetic. Again, inside this, I have to specify color equals species. So now you can see, since I specify this color mapping only inside the geom box plot layer, you can see box plots are colored according to the species type, but the points are black because this color option works only within the geom box plot. Earlier, I specified this within the ggplot layer. Earlier, I specified it here. Then it works on all of the layers. Now I specified it with inside geom box plot. Now it is operating only within that layer. Furthermore, another thing that I'm going to do is I'm going to swap the layer, swap the ordering. I will take another code chunk, I will copy the code chunk. Now I'm going to swap the layers. First, I'm going to add the geom jitter layer. After that, I'm going to do the geom box plot layer. Now you can see in this case, earlier we got first geom box plot and jitter. In that circumstance, first it plots the box plot, and on top of that, it puts the points. When I change the ordering, now it's the other way around. First, it plot the jitter point cloud. After that, on top of it, it put the box plots. So you can see here the points are underneath the box plot. Here the points are on top of the box plot. So ordering of the layers is also important. Okay, so we talked about the basically a geometric layer, mapping layer, and data layer. They are the most important layers. Without specifying these three layers, we can't create graphics. So data, you just introduce your data. Mapping, you map the variables to the graphical properties. And geometries, they are there you specify what we want to see on the graph. Next, let's talk about the scale layer. Okay, before that, I have another layer, statistics layer. Statistic layer is, if you want, you can add summary statistics on top onto the plot. In order to do that, what you can do is you can use stat summary option. You can use stat summary. And within that, you can specify the way the way you want to visualize the summary statistic. So here, what it does is for each value, it computes the summary statistic. Here, just one observation. So the summary statistic. So the summary statistic mean y value is also the same. If you go here, we have some observations for 210. And summary mean of y is denoted by the red color. And here again, just one observation. So the mean of y is also the same. And here, if you go here, this one, we have a couple of values. The mean of y for all of the observations is denoted here red. So you can mark the summary statistics as well. So first of all, here within the layer, you want to explain, you want to tell what how we want to visualize summary statistics. So in this case, I want to visualize summary statistics using points. And then you have to specify what is the summary statistic that you want. I want to represent the mean of y. So fun.y means I want to visualize the mean of y values. And then you can also specify the color, the color for the object. So not just summary statistics, not just individual values. You can also compute summary statistics and visualize them on the chart as well. Actually, there are two ways to visualize summary statistics. One method is you can open a stat layer, stat_summary, and inside that layer, you can specify all of the summary statistics. Or else, what you can do is you can specify another geom layer, geom point. So you can see I have specified a geom point layer. And inside that, I specify summary statistic. Now, instead of using stat summary, I here use stat equal summary. So there are two ways to define, plot the summary statistic. One is define stat function, and inside that we define geom, the geometric type that you want to see on the chart. The other option is we first define the geometry, and inside that we specify the summary statistics that we want to visualize. So we will discuss these things when we come to the examples again. So let's go to the next layer, scale layer. So I told you the geometric layer controls what we want to see on the chart, and scale layer controls the appearance of those geometries. Geom layer specifies what we want to see on the chart. Scale layer controls the appearance of that geometry. For example, here I have 4 variables. I have X variable, Y variable, color, and species. I want to change the appearance of the color, and I want to change the shape. The default colors are red, green, and blue. And default shapes are, can see a circle, triangle, and a square. I want to change their appearance. I want to change the appearance of color, and I want to change the appearance of shape. So what you can do is you can specify scale color, scale_color. That's I want to change the appearance of the color. And I want to change it manually. After that, you can pass some values. Value equal, you can pass, okay, I want to color Adelie type penguins using red. I want to color chinstrap type penguins using blue, and gentoo type penguins using dark color. First of all, you need to specify this color ordering. This is how you should specify it. Color, and then you can use this format. Here you have to specify the category and the color that you want to represent that category. Now after that, you pass this one inside here. The format is, we use scale. The property that we want to change is color. So because of that, we use color. And we want to change it manually. We want to specify the color manually. So scale color manually. So you will get a plot like this. Okay. Another thing that I wanted to mention is if you map a qualitative variable to the color, it will assign a qualitative color scheme. So there's no order in the color scheme. You can see it says Adili, chin strap, and Gento, just red, green, and blue. If you specify a numeric variable to the color, you will get a sequential color scheme like this. Because the numeric value, they have some important meaning. So the color scheme should also represent that ordering. So you can see the bill length, higher values are colored using light green. Low values are colored using dark green. So if you map a numeric variable to the color, it will automatically select select a sequential color scheme. We call this type of a color scheme as a sequential color scheme. This is called a qualitative color scheme. We can't order the color scheme. There is no specific order. This is a qualitative color scheme. But this is sequential color scheme. Colors, we can order them. Dark green, light green, likewise. Okay. Earlier, you can see I changed the colors manually. I specify the colors. Okay, I want to color the red. I want to color the Adelie penguins using red. I want to color the chin strap penguins using blue and the Gento penguins using the dark green. So I did it manually. I specify this a vector. We call this as a vector, and specify inside this scale color manual component. You can also change it using the color palettes available in R. One of the famous color palette is called Color Brewer. So here, instead of using manually, now I'm going to use a color inside this color palette. So this is the color palette. You can see this is, if you type this command, it will display all of these colors. So this is a qualitative. There are so many color palettes, so you can select any color palette from here. In this case, I select a color type called qualitative color type. The name of the color palette is dark 2. So likewise, you can, there are so many color palettes. You can select a color palette from, you can select colors from the color palettes available in R, rather than doing it manually. So Color Brewers, the name of the whole package. And the type of the color palette is qualitative because the qualitative variables are mapping. Color is mapped to a qualitative variable species. And the name of the palette is dark 2. This is another color palette. The name of the color palette is called Viridis. So here this order, we don't need to select anything here. There are some other options we can, if you want to change the colors. But if you do not pass anything, it will give you the default colors in the Viridis color palette. Earlier we did it manually, but you can do this using the color palettes as well. Okay. Some other things that you can do. So if you want scale X, you can change the breaks. So you can see here by default, you will get here 107, 180, 190, 200, likewise. If you want to change the scale, you can now select scale. And the graphical top property that we want to change is X. It's a continuous set of values, and you can specify the breaks that you want. Now you can see only 170, 200, and 230. So the scale controls how we want to see these graphical properties. Likewise, if we go to scale Y log, you will get the log transformed values. Scale color, we discussed. You can also change the shapes manually. There is a shape associated for each and every shape. There is a number associated with that. So you can change the shapes as well. And you can change the alpha value as well. For Adili, I want to see the transparency, set the transparency as 0.6. Gento transparency 0.5. Chin strap for transparency 0.7. Okay. I will explain the facet coordination coordinating. Maybe I can explain the facet. I will explain the case study tomorrow. Then you have a day to do the case study. So I will explain the case study tomorrow. I will complete this part today. Faceting breaks the plot like this. Breaks the plotting panel into sub-panels like this. So here, what I did was, if you run up to this point, you will get all of the data on a single panel. Adili, chin strap, Gento, all on a single plot you will get. Maybe after the workshop, after the lecture, you can run line by line, layer by layer. So the first layer without the plus mark, you can run this part and see how it looks like. And add the second layer and run this part and check the appearance. Now, when you add a facet layer, it breaks the panel according to the levels of the variables that you specify here. Here inside this, within vars, that means variables, you specify the variable that you want to split. So we have 3 species type, Adili, chin strap, and Gento. Now you can see 3 separate panels for each and every 3 panels for on the plot. That's a separate panel for each and every category. We use facet layer to break the plot. And here, if we look at this one, we can see here the x-axis is common for each and every panel. This goes from 107 to 230. Again, this goes from 107 to 230. So that's if they all have the same x range. If you want to make it free, you can specify like this: scales equal free underscore x. Now you can see they get a unique range. Here this goes from somewhere around 107 to 210. This is different, and this goes on up until 230. Similarly, if you want, you can also set y-axis free. If you pass two variables, here in this case, I pass two variables, then you will get a grid like this. The entire plot is split into the 6 categories: female Adélie type, male Adélie type, and here NA means the missing values. And here female chin strap, male chin strap. There are no missing values for chin strap. And so likewise, you can see the other categories. So we use faceting to split the panel according to the levels of according to the levels of another variable. Here we use, if you have a single variable, we use facet wrap. Inside facet wrap, we pass all of these components. If you have two variables, we use facet grid. Okay. Tomorrow I will explain coordinate and themes. And after that, tomorrow we're going to discuss how to perform data visualization using Python. And if you get any questions, you can ask or you can send us an email. Okay, that's all we have for today.
Yes, Tianga, I have a small announcement.
Yeah.
Shall I share my screen? Okay, yeah. Okay, I hope you all can see the screen. So as Tianga mentioned, tomorrow we are going to learn, so today you learn how to do data visualization using R. Tomorrow, during our next session, we are going to learn how to do this data visualization using Python. So this is our workshop website. If you click on this one, it will bring you to this Python this website where you have the Python materials. And if you happen to miss our session yesterday, don't worry. You can access the recording of the Python sessions through this link. Yeah, I have given you a link. If you go to this link, it will bring you to this page. This page contains all the recordings related to the Python introduction. Basically, if you come to this one under reproducible, I started with Python installation and then reproducible research with Jupyter Notebook. Now I have covered the first 3 topics. So if you missed yesterday's session, maybe you can go through that and come so that we can directly move on to this advanced stuff, Python, how to work with Python libraries and how to do data visualization with Python. Yes.
Yes.
That's all I have from my end. Yes, Tianga.
Yes, can you stop sharing? I can show my YouTube videos as well. Yeah. And if you go to